You balance your transportation table using northwest corner or least cost. But is it actually the cheapest way to move your goods? Today, I'm breaking down the MODI method, the modified distribution method, into a complete step-by-step process. Let's get into it. What is MODI method? The modified distribution method, commonly known as MODI, is an optimality test. MODI is an optimality test. In transportation problems, simply finding a way to move goods from point A to point B isn't enough. MODI method is the mathematical tool we use to prove that our current plan is the absolute cheapest one possible. MODI allows us to calculate the opportunity cost of empty routes to see if cheating our shipment will have saved more money. Explanation of relevant variables. Relevant variables used in MODI. To master this method, you need to understand three core variables represented by CUV. CUV. You need to understand the three variables. The first letter C is cost, that is unit cost. You need to understand what unit cost means. This is the price written in the small box in the corner of each cells. You know, you have transportation. We have a number of cells in transportation. So, in these cells, you may see a value, maybe 10, 20, 5, 50, and 30. It represents the cost to move one unit. So these are costs to move one unit. After cost, we have letter U. U is row values. Row values. So we'll be using U to denote the row values. The third letter is letter V, which is column values. Column values. No, these are columns. Vertical. That is columns. In MODI, we use the relationship between these three values, these three variables. We use their relationship in modified distribution. So that means what we want to establish is the relationship between these three values. The C, the U, and the V. We have U plus V equal to C. So that is the relationship between them. This is their relationship. The sum of the row and column equal to the cost. You should take note of that. To unlock the hidden math of our transportation table, you make use of this relationship. Steps for solving MODI. Steps for solving modified distribution. So, to understand the steps are used in mnemonic. I cover. Take note of this mnemonic for the steps. Mnemonic. I cover. Take note of that mnemonic. I cover. I stands for initial. The first letter I. That is initial feasible solution. So it means you will need to obtain the initial feasible solution using any of the northwest corner method, least cost method, or Vogel approximation method. That is the first thing. You obtain the initial feasible solution using any of the methods I have identified. For better understanding, I will advise you watch my earlier video on the northwest corner method, the least cost method, and the Vogel approximation method. The next letter after I is letter C. C stands for confirm. C, confirm. C, confirm. Confirm if the row plus column minus 1 equal the number of the occupied cells. The number you've assigned values, the cells, the number of cells you've assigned values to. If you sum up the rows and column and you subtract 1 from them, it will equal to the number of cells you've assigned value to. So you confirm if row plus column, confirm if row plus column minus 1. Confirm if row plus column minus 1 equal the number of occupied cells. Suppose you have 3 rows, or let me say you have 3 rows plus, and you have 3 columns, minus 1. This will be equal to 5. That means the number of cells you are expected to have assigned value to using either the northwest corner method or the least cost or the Vogel approximation method. The number of cells you are expected to have assigned value to is supposed to be 5. If this matches, you are ready to test for optimality. If it matches, if it is equal to row plus column minus 1 equal to the number of the occupied cells, if it agrees, then that means you can proceed with optimality test using modified distribution method. Remember, I've told you that modified distribution method is a test of optimality. Step 3, which is letter O. O for occupied. Occupied cells. O for occupied cells. Occupied cells are the cells into which assignments are made. When the initial visible solution was obtained using either the northwest corner rule, the least cost method, or the Vogel method, the cell into which the possible assignments were made or are made, that cell is known as the occupied cell. For the occupied cell, use the formula U plus V equal to C, where U equals to row value, V equal to column value, and C is the cost of transportation, that is unit cost of the transportation. This function or equation will be used to form or formulate sets of equations. Then the set of equations formed, the first equation, the one obtained from the first row, you set your first row letter U. You set the U in the first row to 0 and solve for the other U and V values across the table. Across the various equations formed, if after taking the first letter U, the U obtained, the U in the first row, when you take it to be 0, then you solve the various other U and V value across the table. You will understand this better by the time we solve a work example. Step number 4, that is letter V. V for vacant cell. Vacant cells or vacant cell. The cell into which no assignments are made. So you didn't make, when you use the northwest, the least cost or the Vogel method, you didn't assign anything to those cells. The cells you didn't assign anything to. That is the next step. That is what we call the vacant cell. So you evaluate the vacant cells, that is the empty cells. You evaluate it using the formula. The formula for evaluating the empty cell. So C minus U plus V. You evaluate the empty cell using the formula. You already know what U and V mean. If all results are positive or 0, your current solution is already optimal. If all results are either positive or zeros, your current solution is already optimal. That is the solution you obtain using the northwest corner or the least cost or the Vogel. That solution is already optimal if all results are either positive or zeros. No further solution is required. If you get a negative result, a cheaper route exists. That means you have another better solution. You have an optimal solution later. If one is negative, you have something. You know, the objective of transportation is to minimize cost of transportation. You want to minimize it. That means a cheaper route, another one that will be more cheaper, exists if you have any of the values to be negative. Step 5. Where a negative value exists from the result obtained in step 4, then you will need the last step I'm about to take, letter A, which is for adjust. A for adjust. So adjust if you find a negative value. That is, to adjust, what you need to do is identify the cell with the most negative value. You identify the cell with the most negative value, then you trace a closed loop. Trace a closed loop. Shift your units and repeat the process until all vacant cells are not negative. So you will understand this better by the time we solve question. Example, a Z company shows the following data as the plan for the remaining quarters of the year. The interest of the company is to find the optimal alternative so as to minimize cost using MODI method. Quarterly capacity and requirements table. You have the capacity in kilograms, then you also have the requirement in kilogram as well. So you have Calabar, Lokoja, Ilorin. Capacity 300, 250, 200. Total capacity is 750. You have Lagos, Yola, Borno. Requirement in kilogram 350, 200, 200. Total 750. Then we have cost table in 1,000 naira. So we have Lagos, Yola, Borno. Then we have Calabar, Lokoja, and Ilorin. 23, 17, 15. 21, 20, 29. 32, 27, 31. So you want to find the optimality alternative using the MODI method. Now let's have the solution. So the mnemonic for the steps is I cover. So I've told you that the first letter I is to obtain the initial feasible solution. So, but for our purpose, the method to use in obtaining the feasible solution is not stated, but we want to use the least cost method. So this will add more to your existing knowledge, the knowledge you have gained or acquired from our initial video. So now let me have the table, initial table. Let's obtain the initial table. So we have Lagos, Yola, Borno. Lagos. We have Yola. We have Borno. Then we also have Calabar. We have Lokoja. Then we also have Ilorin. They have to and from to this destination and from this location. So go back to the cost table. The cost table, we have 23, 17, 15, 21, 20, 29, 32, 27, 31. So we want to write out the whole values given in the cost table. From the cost table, we have 23 23, 17, 15. These are the values given in the cost table. Then we also have 21, 20, 29. 21, 20, and 29. Then we equally have 32, 27, and 31. These are the costs. Then we have the requirement. Requirement will always be here, which is the demand. The supply, which is the capacity. Capacity, that is the supply. So in case it is given as demand and supply. So back to the question. How much is the capacity and how much is the demand? The total is 750 each. The capacity 300, 250, 200. Calabar, Lokoja, Ilorin. Calabar 300, Lokoja 250, Ilorin 200. So now let's assign it. Calabar 300. This is Calabar. You trace it to it. Calabar total capacity 300. Lokoja, total capacity of Lokoja is 250. Lokoja capacity 250. Ilorin capacity 200. Ilorin 200. Then the demand, which is the requirements. Lagos 350. Lagos 350. Yola 200. Yola 200. Then we have Borno 200. Borno 200. If you sum up this, 350 plus 200, that is 550. 550 plus 200, that is 750. If you also sum up this, 300 plus 250, that is 550 plus 200, that is 750. So demand equals supply. So it is balanced. This is a balanced transportation problem. Remember using the ICOVA step. So you want to obtain the initial feasible solution using least cost method. So we want to use the least cost method. So remember, under the least cost method, the least cost is always our focus for allocation. So if you go through this 15, do you have anything smaller than 15? Among the costs, none. So the least cost is 15. That means the first assignment that you will need to make will start from here. So you want to assign to 15 being the least cost. This row you have 200. This column you have 350. That means because of the 200 you have here, you cannot assign more than 200 to 15 because this row cannot absorb more than 200. If you assign 200 to this, to 15, you have exhausted the whole of 200. You'll be left with 0. If 200 goes out of 350, then you'll be left with 150. So then the next least cost is 21. You have, okay, we have 17. 17 is smaller. But remember what you have here. You have 250 here, but you are left with 150 here. This column cannot absorb more than 150. So you give the 150 to 17. So this 150 is gone. So you'll be left with 0 there. Then if 150 goes out of 250, you'll be left with 100 here. Then the next least cost is 20. Is 20. Or do you have anything smaller than 20? None. So we have 20. Remember, you have assigned 150 to this row, the road where you have 20. You are left with only 100. You are left with 100 in that row. So that means you can give that 100 to 20. So 100 goes out of here, you'll be left with 0. 100 from 200, you'll be left with 100. Now, the next least cost after 20 is 21. This column, you are left with 100. You are left with 100 in this column. So if you assign the 100 to 21, because you have 21 here being the next least cost, if you give the 100 to 21, 100 from 100 is 0 left. Then 100 goes out of 300, you'll be left with 200. Then what is the next least cost? The next least cost is 23. We are left with 200 here. Do we have anything left in this column? 0 left. You are not left with anything in this column. That means you cannot assign anything to this column since you have exhausted what you have in this column. No assignment can be made to 23. So now what is the next least cost? 29. You've exhausted this column too. You can't assign anything to 29. Then the next least cost is 27. You've exhausted what you have in this row. No further assignment can be made to 27. Then after that, the next least cost is 31. Okay? You still have 200 here. 31, you have 200 here, but you've exhausted what you have in this row. That means no assignment can be made to 31. So then the next one is 32. So you have 200 left in this row and 200 left in this column. So you can assign that 200 to 32. 200 from 200 is 0 left. 200 from 200 is 0. This is the possible assignment using the least cost method. Now, what will be the total cost now? Total cost. You have this row, 21 times 100, 21 times 100 plus 32 times 200 plus 17 times 150 plus this is 20 times 100 plus 15 times 200 21 times 100, that is 2,100 plus 32 times 200, that gives us 6,400 plus 17 times 150, that is 2,550 plus 20 times 100, that is 2,000 plus 15 times 200, that is 3,000. So if you sum up everything, 2,100 plus 6,400 plus 2,550 plus 2,000 plus 3,000, the total is 16,050. 16,050. Remember, if all cost is in thousands, that means you add 1,000 to it. That is 16,050,000 naira. That is the least cost you may incur in the shipment if you use the least cost method. Now, after the step 1, from I cover, the letter C stands for confirm. That is the next step. You want to confirm. I've told you that if you want to confirm, you check the number of rows. Rows plus column minus 1. Row plus column minus 1. How many rows do we have? So the row 1, 2, 3. 3 rows. Plus how many columns do we have? 1 column, 2, 3. We have 3 columns. 3 rows plus 3 columns minus 1. So that will be equals to 5. So if that is 5, let's look at the number of assignments. How many cells have we assigned value to? This is 1, 2, 3, 4, 5. The number of cells in which the assignments are made is equals to the result obtained is 5. We have 5. Since it is equal to 5, that means we are ready to test for optimality. This step is confirm. Confirm. This is step 2. So step 1 is obtain the initial solution. That is step 1. The next step is step 3, which is O. O is for occupied cell. Step 3, which is O, occupied cell. So you evaluate the occupied cell using the formula U plus V equal to C. U plus V equal to C. The first occupied cell here is this, which is Calabar to Yola. Calabar to Yola. And the cost is 21. So, Calabar to Yola. Cost is 21. If Calabar is C, that means we have U, which is row. Row C plus column, which is column Yola. V Yola equals to 21. Equation 1. Then the next row. So we have Calabar to Bonu. Calabar to Bonu. And the cost is 32. 32. That means we have U, which is U for Calabar, plus V Bonu. No, V is for column, while U is for row, equals to 32. Equation 2. Then the next occupied cell is this, which is Lokoja to Lagos. Lokoja to Lagos. The cost is Lokoja to Lagos. The cost is 17. So that means we have U Lokoja plus V Lagos equals to 17. Equation 3. Then the next occupied cell is Lokoja to Yola. Lokoja to Yola. Lokoja to Yola. And the cost, Lokoja to Yola, the cost is 20. So that means we have U Lokoja plus V Yola equals to 20. Equation 4. The next occupied cell, we've done Lokoja to Yola. Then the next one is Ilorin to Lagos. Ilorin is row, Lagos is column. Ilorin to Lagos. The cost is 15. So that means we have U, Ilorin, UI, plus V of Lagos equals to 15. That is equation 5. These 5 different equations have been formed. Now, the next thing is to take U in the first row, take it to be 0. Then from this equation 1, in the first row, UC, we take it to be 0. Let UC equal to 0. Then you have 0 plus VY, 0, this is 0 plus VY equals to 21. So, if you collect the like terms, Vy equal to 21 minus 0, therefore, Vy, it will be 21. Is UC plus VB equals to 32. From equation 2. From equation 2. So we have UC plus VB equal to 32. Remember UC is already equal to 0. UC plus VB equal to 32. VB equals to 32. Where UC equal to 0. We've assumed UC to be 0 earlier. That means we have 0 plus VB equal to 32. 0 plus VB equal to 32. So you collect like term, VB equal to 32 minus 0. Therefore, VB will be equals to 32. Now, from equation 3, and the equation 3 is UL plus V equal to 17. UL plus VL equal to 17. Have we know any of this? Check. If we have no UL, Y is also no. Then we've also know VB. We've not know UL, neither have we know VL. So that means since we've not know any of this, we've no VY. So let's go to equation 4. From equation 4. Equation 4 is UL plus VY equal to 20. UL plus VY equal to 20. Where VY equal to 21. VY equals to 21. So you can substitute 21 for VY. So you have UL plus VY is 21 equal to 20. So for UL now. So you have UL equal to 20 minus 21. Therefore, UL equals to minus 1. So you've known the value of UL. So if in equation 3 we have UL. So that means you can substitute for UL in equation 3 in order to get VL. Equation 3. Equation 3 is UL plus VL equal to 17. Where UL equal to minus 1. So that means UL is minus 1 plus VL equal to 17. So we have VL equal to 17 plus 1. Therefore, VL equals to 18. We've gotten the value of VL. So now the next thing is to proceed to equation 5. We've no VL, so we are only left with UI. So we want to solve for UI in equation 5. Equation 5. And our equation 5 is UI plus VL equal to 15. UI plus VL equals to 15, where VL equals to 18. VL is 18. Substitute that 18 for VL, you have UI plus 18 equals to 15. Therefore, UI equal to 15. You have UI equal to 15 minus 18. Therefore, UI equals to minus 3. So we've gotten the value of UI to be minus 3. So that is step number 3. So we want to proceed to step number 4. Now remember our mnemonic is ICOVA. From the ICOVA mnemonic, we've done with I, we've done with C, we've done with O. The next, which is step 4, is step B. And that B is for vacant cell. Vacant cell. And I've told you that the vacant cell are the cell in which nothing is assigned. We didn't assign anything to it. That is step number 4. Step 4. That is from ICOVA, which is V, which is for vacant. Vacant cell. So we want to use the vacant cell now. The cell in which no assignment is made. Now, if you go back to the table, the first one in which no assignment is made is Calabar to Lagos, and the cost is 23. Calabar to Lagos. Cost is 23 naira. Remember, the equation is C minus U plus V. So that means this U will not be UC and this V will be VL, which is U for Calabar, V for Lagos. So the cost is 23. We have 23 minus, what is the value of UC and the value of VL from step 3? We have UC to be 0 and VL equals to 18. We want to substitute 0 and 18 for UC and VL respectively. So we have 23 minus 0 plus 18, which is 23 minus 18. So 23 minus 18, that will give us 5. So plus 5. This cell is occupied. This is occupied. This is occupied. This is occupied. The next vacant cell is this, which is Lokoja to Bonu, and the cost is 27. Lokoja to Bonu. The cost is 27 naira. So minus, since we have Lokoja, U Lokoja plus V Bonu, so which is 27 minus what is the value of UL and the value of VB. UL is minus 1, VB is 32 from step 3, which is minus 1, that is UL, which is minus 1, plus VB, which is 32, plus 32. So this will be 27 minus 1 plus 32, that will be plus 31. So 27 minus 31, that gives us minus 4. So this is negative, minus 4. Then the next vacant cell, Ilorin to Yola, 29 is the cost. Ilorin to Yola, cost 29. So that will be C minus U Ilorin, which is UI, plus V Yola. And the cost is 29. We have 29 minus, what is the value of UI and the value of VY? So UI is minus 3, while VY is 21. UI minus 3 plus VY. Our VY is 21, which is equal to 29 minus 3 plus 21. That will be plus 18. If you subtract 18 from 29, you'll be left with plus 11. Any other vacant cell, another vacant cell, Ilorin to Borno, the cost is 31. Ilorin to Borno, cost is 31. So which is C minus U Ilorin plus V Borno. So our C is 31 minus, what is UI? UI is minus 3 and VB is 32. UI minus 3 plus VB 32, which is 31 minus 3 plus 32, that will be plus 29. So if you subtract that, 31 minus 29, that is plus 2. If you look at all our results, you have one negative. Since I've told you that the optimal solution is achieved if everything are either positive or zeros. The last step is to adjust. And I've told you to adjust, that means you have to identify the cell with the most negative and trace a closed loop. So we only have minus 4 in one place, and the cell that gives rise to that is the cell between Lokoja to Borno. We have to identify that. So go back to the table. This is Lokoja to Borno. Let me draw the final table. Final table. So we have Lagos, we have Yola, we have Borno, then we have capacity, then we have Calabar, we have Lokoja and Ilorin, Lokoja, Ilorin. So this is from, this is to, and the cost 23, 21, 32. 23, 21, 32. Then we have 17, 20, 27. 17, 20, 27. 15, 29, 31. 15, 29, 31. So you have 150. This is requirement. 150. 350. 200, 200 total. We have 350, 200, 200. Total is 750. Then we have 300, 250, and 200. Lokoja to Borno. That is where we have -4. If you look at the assignments that were made earlier, here you have 100. Here we have 200. Here we have 150, 100, 150, 100. Then here we have 200. So these were the assignment that were made. So we want to trace a closed loop between Lokoja and Borno. Between Lokoja and Borno, the assignment that was made, the lowest one should always be used. If you use 150, you will turn out it will be wrong. So the adjustment. Lokoja to Yola. Lokoja to Yola, because the 100 we want to subtract is under Yola. If 100 is subtracted from here, that means the only assignment left here is 150, and here you have 250. So that means 100 have to be added to another place within this. So we add that 100 to this place, which is Lokoja to Borno. Lokoja to Borno. We add 100. So we add the 100 here. If that 100 is added, 200 plus 100, that is 300, which exceeds this. That means we have to reduce the assignment here so as to bring back these 100 so that we can now have 100 plus 100, making 200. So let's subtract 100 from Calabar to Borno. Calabar to Borno. Subtract 100. If you subtract 100 from here, then you'll be left with, from 100 from 200, you'll be left with 100. So that means you are left with 100 there. So 100 plus 100, that is 200. This one balanced. But this 100 plus 100, that is 200. It doesn't agree with 300. That means we have to add that 100 again. You know, we have subtracted 100 from here. You have to add the 100 you subtracted from here back to somewhere else. So we add that 100 back to the 100 we have in the assignment here. So add, that is, if you want to add it to here, that is Calabar to Yola. You already have 100 here. So we have Calabar to Yola. Add 100. If you add 100, this one will increase to Calabar to Yola. It will increase to 200. So if you add 100 to the 100 we had there earlier, so it increased to 200. So 200 agrees with this. 100 plus this, that is 300. Then here 150 plus 100, 250, 200. So it agrees. Column 350, 200, 200. So this is the final table. Total cost now equals to 21 times 200 plus 32 times 100 plus 17 times 150 plus 27 times 100 plus 150 times, 15 times 200. 21 times 200, that is 4,200 plus 32 times 100, which is 3,200 plus 17 times 150, we have 2,550 plus 27 times 100, which is 2,700, plus 15 times 200, that is 3,000. So if you sum up the cost, we have 4,200 plus 3,200 plus 2,550 plus 2,700 plus 3,000. We have 15,650. Remember, the all figures are in thousands, so you have 15,650,000. So this is the optima, so which is lower than the original cost of transportation we obtained earlier from the least cost method. So this is the optimal solution. If this guide helped you, please like, share, and subscribe to support the channel. What topic would you like me to break down next? Let me know in the comment below. See you in the next class.